So today we are going to be learning about special right triangles. Now in your notes and in class in general, I did this in reverse where we did day 2 first and day 1 the second day. Well, technically we haven't even done the first day because it's a snow day or ice day. So I'm going to start with the day 2 because we haven't learned that yet. And then we'll go into 30, 60, 90 if you have not watched that part already or if you were gone on the day we started 92. Anyways, we'll start with 45, 45, 90 degree triangles. This is a special right triangle. There's two special right triangles, 45, 45, 90, and 30, 60, 90 triangles. They all have special properties. Well, not special properties, but there's some case scenarios where like the dimensions of these triangles work out nicely, and they are pretty relevant once we go into further math topics, but we're not going to dive into those in geometry. You can dive into them more in Algebra 2 and in pre-calc. But to get a gist of 45, 45, 90 triangles, there's one key statement that we can build off of with seeing these kinds of triangles, and that is the fact that the hypotenuse is square root 2 times as long as each leg. So that means the hypotenuse, in this case, this side right here, is square root times larger than both of these legs. Given that the legs are the same, they are n. Each leg, maybe if you need to make a note, legs are congruent. They equal the same side length, or they equal the same value. If you need to make a note of that, please do. And then with this statement right here, we can build a general equation when it comes to like working with these functions. Not two, just one. That general equation, I'm going to throw that paper off the desk. This general equation would be working with the hypotenuse, and it states that the hypotenuse, looking at our statement, hypotenuse is square root of 2 times as long as each leg. We know that a leg is n in length, so it'd be n times the square root of 2. All right, to see why this triangle is so special and why we have a hypotenuse that is square root of 2, it kind of dives into the basic structure of how this triangle can be set up. Let's just say we have a triangle as such. Oh, that is such a pet. That's not even a triangle. That's a trapezoid. Triangle as such, like so. We have a triangle like this. It's a right triangle, and given 1 and 1 for each of its side lengths. Now, I don't know what the hypotenuse is right here, so we call it x. And when we work with the Pythagorean theorem, doing c squared is equal to a squared plus b squared, when we start plugging our values in, knowing that x is our c value, since it's the hypotenuse, we'll have x squared is equal to 1 squared plus 1 squared. Combining everything together, we'd have x squared is equal to 1 plus 1. X squared is equal to 2. And then giving that square root, doing the inverse of a square, which is rooting it, giving the square root, we'd have x is equal to square root of 2. Which leads us to having x actually be the square root of 2. So, yeah, it works out in the end because now this works out in the end because when we start labeling everything, referencing back the model picture, of our triangle itself, with both legs being the same length. We have that right here. We can call those n. And since 1 times anything would be that new value, we can say that the hypotenuse is n times the square root of 2, which gives us our formula up here. Kind of a nice little visual of seeing everything get played out, of why this formula gets made and why this triangle is kind of significant. It's a little proofy proof thing. Honestly, I had a better idea of what I wanted for this section, but I don't have my paper that I wrote my instructions down at home. It is at work, and it is an ice day, and I am not going in to go get it. So we deal with it. Anyways, with knowing the function in the equation that works with 45, 45, 90 triangles, I can use this to my advantage to solve for x and other missing variables when I'm given that problem or given problems. Like with example A, I need to find out what x is right here, and I'm given some various numbers. Seeing that I have 45, 45, I can use my hypotenuse is equal to n times square root of 2. Remembering that n is a leg. X is my leg here, so if I need to, I can label it as a leg. 5 is opposite of my right angle, which makes this my hypotenuse, which is my longest side on my triangle. And now I can set up my equation of hypotenuse is equal to n times square root of 2. And that's going to lead me to doing 5 is equal to x times the square root of 2. Now I need to get x by itself. So I'm going to divide by the square root of 2. And I'll end up with x is equal to 5 over the square root of 2. But I'm not done here because I want to get rid of the square root in the denominator. So I need to multiply both the top and bottom by the square root of 2 to cancel out that square root. So I'll end up with 5 square root of 2 over square root of 4, because 2 times 2 is 4. Since I'm still in the square roots, I have to keep it in the square root. But 4 is one of my numbers that I can take the square root of and get a nice number. So I would end up with 5 square root of 2 over 2. And that's where I'm ending my problem for x, because this is as simple of a form for x as I can get. This is not as bad as 30, 60, 90, as you'll soon see when we start doing problems. It's not as tricky. Looking at B, I am given x and I'm given my legs. Both legs are the same length, so that means our hypotenuse right here, x, because it's opposite of our right angle, will be times square root 2, as big as our leg right here. I'll note that this is the hypotenuse, and now I can lead to my setup of doing the hypotenuse is equal to n times square root of 2, n being my leg. Now subbing in everything, I'd have x is equal to 4 square root of 2 times square root of 2. And then I can start solving. I know the square root of 2 times the square root of 2 is equal to the square root of 4. So that means I'd have 4 times the square root of 4. I can take that square root of 4 and make it 4 times 2, because the square root of 4 is 2, which will lead me to having an x equal to 8. Again, this isn't that bad compared to 30, 60, 90 from what you guys did yesterday. This is pretty nice. Nice and easy going compared to the others. Now, I'd say, okay, now you try these. But no, because you are at home. So I get to try them. So we need to find the value of x. So cool. x for a is the hypotenuse, by the way. Sometimes I forget to draw and everything. I've been realizing that. I need to double check my work before I print. Anyways, this x right here is opposite of that hypotenuse, or opposite of that right angle, so that means x is our hypotenuse. Which means that 22 and 22, since we have two 22s, these are our legs. They're both a leg. They're both congruent to each other, which means that this is a 45, 45, 90 triangle. So that means when I set this up, with the hypotenuse is equal to n times the square root of 2, which n is being one of my legs. That means I will have x is equal to 22 times the square root of 2. And from there, I cannot do anything else. This is as simple as my equation's going to get. So that means x is going to be 22 square root of 2. Can't simplify that 2 down because the square root of 2 is 1.4142 and so on. I think that was actually starting to be right. So good job. Good job. Going on to B, I have x and x. Those are my legs. They're both x. And then opposite of my right angle, I find my hypotenuse, which is 10 square root of 2. So that means when I set up my equation, hypotenuse is equal to n, which is my leg, times the square root of 2. I will have 10 square root of 2 is equal to x times that square root of 2. Now, seeing that I have x and x for my legs, only need to put one of the legs in. I don't have to do like x squared. It's just x, because it's only one leg times the square root of 2, since both legs are the same one. So now I need to get x by itself. So I'm going to divide by that square root of 2. So I will end up with x is equal to 10 square root of 2 over the square root of 2. I need to get rid of the square root of 2, so I need to multiply both the denominator and the numerator by the square root of 2. And then that means I will end up getting 10 square root of 2 times the square root of 2 over the square root of 4, giving me 10 square root of 4 over 2, which will end up being 10 times 2 over 2, which is 20 over 2, giving me 10 for my x. Going into our last problem, we have that Fenton High School's baseball diamond has an infield with the dimensions of 90 feet by 90 feet. And our goal is to find out how far the catcher will have to throw from the home plate all the way to the second base. Now, knowing baseball terms, this is the home plate. This is second base. And ruling out, drawing in what we know, the dimensions. Infield would be the baseline, going from 90 feet to 90 feet. And I want to find out the distance from home plate to second base. I want to see how far that catcher has to throw to second base. So that means when setting up my problem, it looks like I have, first off, a 90-degree triangle with two congruent legs. So that means I can use the 45, 45, 90 base equation to help me find out what this question mark is. Giving that this question mark would be the hypotenuse. So that means I can use hypotenuse is equal to a leg times the square root of 2. And then I can find out or sub in what I know, which is the fact that I have the hypotenuse, which is my unknown, is equal to 90 times that square root of 2. And since I'm trying to find out distance, how far the catcher is going to have to throw, I'm going to calculate out 90 times the square root of 2, which is going to give me about 100 and 27.28 feet. That's how far the catcher is going to throw from home base to that second base plate. Hopefully they got somebody out that was trying to steal the plate. Anyways, that's it for 45, 45, 90. Now we're on to day 2, which is 30, 60, 90 triangles. Now, given 30, 60, 90 triangles, there's a few things we need to also note about this. One thing that we need to note is, first off, that the hypotenuse is, and I'll write it in a different color this time. I should have done this before, but write it in a different color. Twice as long as the short leg. Given that this is the hypotenuse, finding it is 2n. N is smaller than 2n. This is going to be the short leg. Because if you divide the hypotenuse by 2, you'd end up with n. It's twice as big. Second, the longer leg is, write it in a different color, square root 3 times as long as the short leg. Seeing this right here, this is the long leg. It is square root 3 times bigger than n, the short leg. With those two statements, I can write out a general formula. My first formula is going to deal with the hypotenuse, and that is the fact that we will have our short leg multiplied by 2 to get our hypotenuse. That's our first base equation, and our second one would be our longer leg is equal to our short leg times the square root of 3. Gotta make sure I bubbled this one in green. I was about to bubble the longer leg with green. It wouldn't have connected. Well, it would have been fine, but it wouldn't have looked like consistent. These are two equations that we can form for 30, 60, 90 triangles, and the two that we will be using in the following examples. Like with example 1, we need to determine what x and y are. Given that, looking at the picture itself, it's a 30, 60, 90 triangle. Going opposite of this right angle, I end up finding my y, which the opposite side from that right angle is always the hypotenuse, so y is going to be my hypotenuse. Looking at where 30 is on my triangle, if I go opposite of 30, I'd hit x, so that's going to be my short side, or short leg. One thing I need to mention about what I just did, going to my 30 angle and finding my short leg. This is something we've worked with a little bit before, but if you go to the smallest angle on a triangle and you go to the side opposite of it, that's going to be the shortest leg. Or we can even look at the triangle we have up here to better illustrate it. Looking at the smallest angle on this triangle, it's 30. If I go opposite of it, I will find it's the shortest side on a triangle. In this case, I get to the short leg. If I go to the largest angle on this triangle, which is the 90-degree angle, and I go to the opposite side, I'd end up getting the hypotenuse, which is the longest side, the longest leg of a triangle. And then if I go into the middle, I go to 60, or I'm at the 60 angle, that's between 30 and 90. If I go to its opposite side, I'd end up getting the side that's in between both the shortest side and the longest side. That's how I was able to find out that x was the shortest side. And that means 9 out of process of elimination is going to be my long leg. So when setting up to find out what x and y are, I need to kind of piece together and pick out which equation I have to start with first in order to first use all the viable information I know in order to solve for x and y. Like, the hypotenuse is equal to the short leg times 2. I can start with that, like writing it out. Like, we can write the hypotenuse is equal to short times 2. But when I start plugging in my information, I'd only have y is equal to x times 2. I don't have all my information yet, so I can't really find the hypotenuse yet. So I'm going to have to start with the longer side, or well, the long leg is equal to the short leg times the square root of 3. So doing long is equal to short times square root of 3. Plugging in my information that I know, I'd have 9 is equal to x times that square root of 3. I can divide by square root of 3 and end up getting x is equal to 9 over square root of 3. And I don't like that square root of 3 in the denominator, so I got to multiply it to the top and bottom, leading me to have 9 square root of 3 over the square root of 9. That can simplify down into 9 square root of 3 over 3. By taking the square root of 9, I'd end up getting 3. And since I have a 9 and 3 right here, those are divisible with each other. We can take a factor out, which divide both of the numbers by 3. I'd end up with 3 square root of 3 for that x value. I'll bubble that in. Now with that x value, 3 square root of 3, I can find out what the hypotenuse is. So plugging in that information, I have y is equal to 3 square root of 3 times 2. And remember, this 2 is outside of a square root. So it's not over a square root. So that means we're not going to have to multiply it with this square root of 3. It'd just be multiplying with that 3 on the outside. Remember that 3 square root of 3 can also be written as 3 times the square root of 3. So I can move my values around because it's all multiplication. Doing that, if I did want to move my values around, I can do 2 times 3 times that square root of 3, leading me to get a 6 square root of 3 being my final answer. It's not too bad. As long as we know how to work with radicals, the problem is not bad. And they really aren't. We just need to get used to working with radicals. Going to example 2, more of the same thing. I need to find my x and y. This is supposed to be a right angle, but this was a missing angle, and you needed to find out what it was. Now, given that we have 60 and 90 here, you could do 180 minus 90 minus 60 to get 30, meaning that this would be 30 degrees. With that information, we can start plugging away and figuring out what sides are what. Finding out what side is the short side and what side is the long side is probably the hardest part, because the rest is just plugging into the equations. Looking at 30 right here, this is my smallest angle on my triangle, given that I have 30, 60, and 90. So going to the opposite side, I'd end up on this side right here, which is with y. So that means this is going to be my short leg. Looking at my right angle, which is my biggest angle, I can go to its opposite side to find the hypotenuse, which is going to be 30. So since I have my hypotenuse and short leg, that means x right here is going to be the long leg. Now I can start building up equations. I know my hypotenuse, but I don't know my short leg and long leg. So I think at the start of this problem, we should be using the hypotenuse is equal to 2 times the short leg. Since I know the value of my hypotenuse, it'll make finding the short leg a lot easier. So that means when setting up my equation, the hypotenuse is equal to short times 2. I will have 30 is equal to y times 2. Dividing by 2 to get y all by itself, I'd end up with a y is equal to 15. Now, since I have my short leg, that means I can start finding my long leg. Our long leg is equal to the short times the square root of 3. So that means when solving this problem and plugging in my information that I know, I don't know my short side, but I'm given a variable, which is x. I do know my short side because that was my y that I needed to find, so that's 15, and it's multiplied by the square root of 3. Now, since 15 is on the outside of that square root, I don't have to simplify anything, especially since it's not over a fraction, so I don't even have anything to simplify for 15. And I can't reduce 3 down because it is as small as it can get before it just starts being a decimal. So that means my x will just end up being 15 square root of 3. Sometimes our problems is just plugging in our information and then we get our answer. Sometimes you don't even need to simplify stuff down. That's the beauty of trig. You don't even need to do too much work. Or beauty of radicals. You don't have to do that much work. Now, given problems, we are also going to be doing story problems. In more real-lifey problems, you'll see more real-life examples given in problems. Like in example 3, we need to find out how high the end of a 54 feet long ramp is when the tipping angle is 30 degrees. Now, tipping angle is just how high the angle is, or like how big this angle of elevation is going up. And we'll learn about angles of elevation later, but it's how much that angle is rising up. In this case, it is 30 degrees. We need to find the height of the ramp, so the tippy top of it, but from the top to the bottom, I need to find out what this side is. This is my end goal, and I know that the ramp itself is 54 feet long. The ramp being this side right here, which coincidentally, it is the hypotenuse because if we go from the right angle all the way to its opposite side, we hit to 54 feet. So that means this is going to be our hypotenuse. I have 30 right here, which is the smallest angle on this triangle because that means if I do 180 minus 90 minus 30, I can find this missing angle up here, which is 60. So that means 30 is my smallest angle. So if I wanted to find the shortest leg, that means I'd have to go from 30 all the way to its opposite side. And look at that. We're at the height of the ramp, which is going to be our short leg. So that means when setting up my equation, I'm going to be using the hypotenuse is equal to the short leg times 2. Since I have the hypotenuse, and since I'm finding the short leg, this is the easiest equation to set up with. Especially since I have no idea what the longer leg is. Now, when plugging in my information, I have 54 is equal to that short leg. Let's give it h being for height. That's my variable times 2. I want to get h by itself, so I'm going to divide by 2 and end up getting an h of 27 feet. So the height is going to be 27 feet on our ramp. Now going down to the final problem. Due to bad weather, Mr. Rose, who is a part-time pilot, must alter the flight by 30 degrees. The plane will land at Airport B instead, which is 46 miles away from Port A, which was the original port I was going to land at. How far will the plane have to travel to reach its new destination? When given a problem like this, it's always good to start by drawing a picture. Given that this is the plane right here, and assuming that Port A was a straight shot, we're going to start with a figure like this, a picture. And knowing how directions work, maybe having to draw in a compass, We're remembering what directions go with what. West is generally to the left, especially when we're doing drawings. So that means since this is 46 miles west of port A, port B is going to be to the left of port A. And we know the distance, which is 46 miles. And my goal is to find out what this distance is going to be from the plane to the new port. And one thing I can also fill in is that I had to change my trajectory by 30 degrees. So this angle is 30 degrees. Given that this is a right angle, since we're going from north to west, this is a right angle, given how a compass works. So that means finding out what this angle is, doing the same thing that we did up top, this would be 60. So that means 30 is my shortest side or shortest angle, so that I can find the shortest leg. Going directly to the opposite side, I'd end up getting 46. So that means 46 is my shortest leg, or the short leg. I need to find out what this is right here, the distance from the airplane to B, which is going to end up being my hypotenuse, since it is opposite of that right angle. So when setting up my problem, I will have the hypotenuse is equal to the short leg times 2. And filling in my information, I have that hypotenuse right here that I need to find is equal to the short leg, which is 46 times 2. And doing 46 times 2, I'd get 92 miles for my final answer from the plane itself to port B. And that is it for 30, 60, 90 triangles. One thing that I wanted to do, especially in class, and one thing that is going to be consistently happening throughout the whole unit for trig is a unit story. And this deals with applications of everything that we have been learning so far, and it's going to be based in a story problem. And this story will unfold as we go out through this whole unit, so pretty much the rest of March. Now, going through this unit, we'll be seeing a story unfold of Mr. Rose going on a picnic. As the story progresses, there will be problems for us to solve. Over the course of the packet, we'll be able to solve the problem at hand that I am currently facing. The question at hand, Mr. Rose is getting ready for a picnic this afternoon, and he plans on bringing a peanut butter and jelly sandwich along with him and other treats. He is as tall as the fridge and is standing 15 inches away from the fridge. The peanut butter is in the cabinet 8 inches above the fridge. The jelly is at the bottom shelf of the fridge, and if he were to reach out for the jelly, he would be 113 inches away from the jelly. With the given information, determine the height of the fridge and how far away the peanut butter is by arm's length. Now, we're not going to take human proportions we're not going to say that the proportions of my body are going to be humanly viable in this example. Sometimes maybe my arms are freakishly long today, but there's some information that we need to pull out of this big question. And in class, you would have gone into groups and tried to solve this for your own self. In this case, since I am currently at home recording this, I am going to be the group itself. So, one thing we can pick out is that he is as tall as the fridge. Height of Rose equal height of fridge. I'm going to abbreviate. and he is standing 15 inches away from that fridge. The peanut butter is 8 inches over the fridge. So 8 inches above fridge. PB is. And the jelly is 113 inches away from Mr. Rose. And in specific, from arm's length. Our goal is to find the height of the fridge and how far away the peanut butter is from arm's length. All right, so this is where drawing and diagramming this out comes into play. And what you guys need to get used to, especially starting in the next block of this chapter, is drawing out your problems. It's going to make everything so much easier. Now, granted, this is a very, very, very loaded question, but being able to draw, if you can draw out this question, you'll be able to draw out every other question. And it'll make it a lot easier for your life. So, drawing out this diagram, let's just say I'm right here, and the fridge is my height. So we can draw a block right here. Same height, given. There is a shelf above here that houses the peanut butter. PB. We know that this shelf is 8 inches. And I'll zoom in now, so you can actually see what I'm drawing better. We know that this is 8 inches above. All right. Now, our goal. Oh, also, we know that I am 15 feet away. Or 15 inches away. And I'm going to I should put in the marks there. 15 and 8 inches. We also know, and we'll cross out what we already have worked with. We have the diagram ready. Or at least, like, I am the height of the fridge. We got that good. I'm 15 inches away. We drew the peanut butter in. And now I got to put the jelly arm's length. So if I drew arm's length, it'd be 113 inches away. Put J down here for jelly. My goal is to find the height of the fridge. So we'll do FH for height of fridge. And I need to find arm's length. So of the peanut butter. So we'll do PA for peanut butter arm's length. I should do PBA. Actually, PBA for peanut butter arm's length. So those are my goals. That's my diagram and what I'm going to be working with. Now, given the picture itself of what I just drew, little convoluted, but we can kind of see things forming and triangles forming. So what might be useful is to break apart the triangles that we are working with. I will be using, for this problem, the height of the fridge will be green. So my FH will be green. So when I find the height of the fridge, and for finding the PB, the peanut butter at arm's length, I'll be using blue. I'm going to draw a separate picture for both of these triangles that are formed. Given how this looks, it'd be very hard to work in context of that. We'll start with FH, finding the fridge's height. So, drawing out another picture, or just blowing this out, I have 15 inches right here between me and that fridge. And I need to find out the height of the fridge. This is FH. And from arm's length to the jelly, it is 113 inches away. Looking at how things are working in my picture, I am 15 feet away, and I'm trying to find the height of the fridge, which is vertical. So we're going horizontal and vertical with our lines. That's going to make a perpendicular, which means that this is going to be a right triangle. So, since I'm working with a right triangle, that means I can use the Pythagorean theorem to help me find out what FH is. So, looking and trying to figure out what that C value is for the Pythagorean theorem, I need to go opposite of my right angle to find out what that C is. So going opposite, I find that 113 is going to be the C value that I work with. So that means when setting up the Pythagorean theorem, and we'll do it off to the side here now, since I'm a little bit running out of room, we'll have C squared is equal to A squared plus B squared. I need to put 113 inches right here, because that's my C, and that's going to be equal to 15 squared plus FH squared, because that's the fridge's height for what I am trying to find. And now we can start simplifying things. So I have 113 squared, which will give me 127.69 is equal to 15 squared, which is 225 plus FH squared. Subtracting 225, we will end up getting 125.44, which is equal to FH squared. And now to cancel out that square, I need to take that square root. So when I take that square root for FH, I will end up with 112 inches. So that means the height of the fridge, so fridge height, is 112 inches. All right. Now we can work on PBA, finding the arm's length reach for that peanut butter, drawing out the diagram that I have. We have 8 inches and 15 inches. Since the peanut butter is on a cabinet all the way up 8 inches above that fridge, I am 15 inches away from that fridge. Looking at the base diagram that we have here, where we're dealing with a horizontal line and then going vertically up. So that means we will have a right angle. And my goal is to find the arm's length, which is PBA. I can use the Pythagorean theorem since I'm dealing with a right triangle and that I have 2 side lengths. I can find out what that other side length is. Going to the opposite side of the right angle, I'll find that PBA is my C value. So when using the Pythagorean theorem, I will end up doing C squared is equal to A squared plus B squared, which will get me to have PBA squared is equal to 8 squared plus 15 squared. PBA squared would be equal to 64 plus 225, which means that we'll have 64 plus 225, which is equal to 289. Doing the inverse of a squared is doing a square root. So that means PBA, the peanut butter at arm's length, will be 17 inches away from me. All right. So we found out the arm's length away that peanut butter is going to be and the fridge height. Next question is that, are we working with Pythagorean triples? Now, when checking if we're working with Pythagorean triples, it means that does c squared equal the sum of a squared plus b squared? So when checking it, we can check our work. So 113 squared So we need to check 113 squared is equal to 112 squared plus 15 squared. When we do that, we'll have 127.69 is equal to 125.44 plus 225. When we do 125.44 plus 225, we get 127.69. Which is the same number. So yes, we have one Pythagorean triple. So we'll just say yes for fridge height. That's a Pythagorean triple. And for the PBA, we know already from 9.1 that this is one of our common Pythagorean triples. So we can note that this is a common Pythagorean triple. So yes, we have a triple. And now we need to check if we have any special right triangles. So, looking at our triples and our side lengths on our triangles, it looks to be that we do not have the case of we don't have the case of 45, 45, 90. So no 45, 45, 90 triangles. Legs aren't congruent. Because we know that 112 is not the same as 15, and we know that 15 is not the same as 8. Those are our legs on our triangles, so they're not going to be 45, 45, 90 triangles. Now to check if we are working with 30, 60, 90. And seeing if this is a 30, 60, 90 triangle, let's start working with, we need to check. We need to confirm. We're going to confirm both of them. The easiest way to confirm if this is going to be a 30, 60, 90 triangle is using the hypotenuse is equal to the short leg times 2. If this doesn't mathematically work out, then we can say that this is not a 30, 60, 90 triangle. So testing our first triangle for the fridge's height, our hypotenuse here is 113. And our short leg would be our smallest leg. Given that one of our legs is 112 and our other is 15, I will have 15 times 2. When simplifying this out and mathematically doing it, I'd have 113 is equal to 30, which is not equal to each other. So that the fridge's height triangle, the one that we worked with green, is not a 30, 60, 90. Now going to PBA, I know that 8 is my shortest leg because I have the side lengths 17, 15, and 8. So that means I'll have 8 times 2 is equal to that hypotenuse, the longest leg, which is 17. Mathematically doing it, I'd end up with 17 is equal to 16, which is oh so close to being a 30, 60, 90, but it is not the case. So we can say that it doesn't work. Does not work out. And our proof is in the red. That's all the questions that we're working with. And since our sandwich is made, we can go on a fancy picnic. And we'll continue this story arc later in the unit when we start working with stuff after the quiz. Hopefully you guys enjoyed this nice little vacation you have from Thursday. And I will see you for the next lesson.